my calculus cherubs. Welcome to your review for the Chapter 2 test. This is the first half of Chapter 2, as you can see, 2.1 through 2.4, which is pretty much predominantly 2.1 through 2.3. You can see the scoring rubric on the right. Wrong rule used, chain rule not used, incorrect algebra, does not simplify correctly, improper or missing notation. Remember, notation is the easiest point, so please don't mess it up. There's nothing I have to rewrite here at number 1, so I'm going to go ahead and do y prime. It's going to be 3 times the derivative of sine. Derivative of sine is cosine. 5x squared. Now I need to do the chain rule. I'm going to multiply by the derivative of what's inside this guy right here. So the derivative of that would be 10x. And all you would have to do now is simplify accordingly. By that I mean let's multiply 3 times 10x, that's 30x, times the cosine of 5x squared. And that's where you can stop. Okay? So numero uno is finished. That's what we're looking for. Okay. Let's move down here a little bit. Number 2. I am going to rewrite number 2 in a more friendly format without the radical. So notice I did not write y prime. That would be inappropriate because I have not taken the derivative of this. So this will be to the 7/6. Now I'm going to go ahead and derive this. So this is a good chain rule problem. The 7/6 comes out in front, and I'm being multiplied by 4x to the third plus 2x plus 1. Subtract 1 from this to get 1 over 6. Now, remember, we are not finished. I still have to do the derivative of the inside, which is this guy here. So I'm going to have 12x squared. 3 times 4 is 12, subtract 1, plus 2, and then the derivative of that is 0, so I don't have to write it. So I'm going to put plus 0 on the end, and 2 plus 0 is going to give me that 2. So really all I need to do is, there's nothing really I can simplify here, because this is all under the radical. I could distribute 7/6 into that, but I would accept this. I mean, or you could really write it as, let's see here, that would be 14x squared plus 7/3. So, you know, either one's fine. You could have that times 4x cubed plus 2x minus 1 to the 1. Okay, either one of these is completely adequate. Okay, all I did here was I multiplied this into this, and to be honest with you, you could probably leave it like the top one, or you could write it as the bottom. Either one is fine. Going to 3. Too far. Okay, I am not going to rewrite the one in the middle. By middle, I mean negative 2x to the negative 5th. I'm, however, going to rewrite this, which would be pi times x squared. So I'm going to derive this one piece at a time. So y prime, this will be positive 10 x to the negative 6 plus 2 pi x to the first. So I could leave it like this. Okay, if you really wanted to put the x in the bottom, you can. It's not going to really matter. I would not take any points off if you left it like above. Either one of those is fine. All right. So number 3 there, it's all about recognizing how to rewrite the original. Right. Moving straight down here. Moving right along. Everything looks ready to go, so I can go ahead and write in y prime. Derivative of x is 1, so I have 1 pi. Now I need to do chain rule here. So 3/7 is going to go in front of my 9x cubed plus 2. I'm subtracting 1 from that, which is basically minus 7 over 7, so I'm at negative 4/7 when I take the derivative. Now I still have to do the chain rule, so I need to multiply by what's in here, so that would be 27x squared. As far as simplifying, the only thing I can do is really put those fractions together. Y prime. Pi is not going to be touched. I'm going to have 3 times 27, which would be 81 over 7. And I still have an x squared here. And I'm going to leave 9x to the third plus 2 to the negative 4/7 just as is. Okay. You could put this on bottom. That's fine. Okay. But that's where you can stop for number 4. again, shift down here. Okay, I'm not ready to do quotient rule yet, so I can rewrite this in a more friendly form. Notice again, I am not writing y prime. I'm still writing this as y. So I get rid of this negative when I shift it to the top. That's my situation. So this looks like chain rule again. Okay, so y prime, this would be negative 4 times, bring this 3 out, 3t squared minus 4t minus 1. This is now squared. Times, now I need to do the chain rule. What's the derivative of the inside? So this would be 6t minus 4. All right? So put some of this stuff together. This is negative 12, all multiplied into this guy because I have no exponents. So negative 12 times 6 is negative 72t, and negative 12 times negative 4 is positive 48. And this is going to be multiplied by 3t squared minus 4t minus 1 all squared. That's fine. Okay? You may not leave this as negative 4 times 3. I would not get too upset, or probably not take any points off if you didn't distribute the 12 into this. But you definitely have to write this as negative 12 times this times this. Okay, so that's how I would finish it. All right. Now we're going to start finally getting into some that will make you think a little bit. Some trig functions. All right. So there's nothing I can rewrite there, so I'll go ahead and y prime this. I'm going to do the derivative of sine, which we know is cosine. I still have 15x times the chain rule, so the derivative of this is 15 plus 5 times negative, jump the gun, missed that little 3 up there. So I'm going to take the derivative of this 3 first. So this will be 3 cosine squared of x times, what's the derivative of cosine? Negative sine of x. And derivative of x is 1. So that would be the chain rule twice. Don't forget this exponent goes out, that's what you do first. Alright, so let's simplify over here. This will be negative 45 cosine of 15x. So he's pretty user-friendly. Let's take a look here. It's going to be minus now because I have a negative times all these positives. So we're looking at 15, minus 15. This is cosine squared of x, sine of x. Okay. If you wanted to pull out a GCF of negative 15, by all means you can do that. I am not requiring you to do that. So this is pretty much where you would be able to stop that one. All right, so there's number 6. Lucky 7. This is now part 2. Looks like we have product rule. So here's a good example of product rule. So we'll go g prime of x. I'm going to take the derivative of the first one the first time and rewrite the second. Then I'm going to add to that the derivative of the second one times the first one. Translation. Let's derive this one. So this is 4 times 2 minus 3x to the third times the derivative of the inside, which is negative 3, times 6 cosine of x plus. Remember, that's the quotient rule. So what I did here is took the derivative of him and multiplied by 6 cosine of x. So there's chain rule in here too, but now I'm doing product rule. So now I'm going to do the derivative of, well, I'll rewrite the first one in a while. And now I'm going to do the derivative of the second one, which would be 6 times negative sine of x. It's negative there. Okay? Now we got to do some simplifying. So g prime of x looks like we have 6 times 3 times 4. Or I could do 12 times 6. This looks like negative 72. 2 minus 3x to the third cosine of x plus, let's see here, nobody can go together here. Actually, it won't be plus, it'll be minus. So this will be, minus 6 2 minus 3x to the 4th sine of x. Okay? You could always pull GCF out again of 6 times 2 minus 3x to the 3rd. It's really not going to change a whole lot. So, I could allow you to stop here. I'll pull a GCF out here quick. Let me pause it, and I'll show you the work so I have time to get more on this video. So as promised, I pulled out a GCF of -6 and 2 minus 3x cubed. You can see here all I have is left is a 12 cosine of x. This will be plus 2 minus 3x it still has in the sine of x. So it really didn't enable me to combine any like terms. That's why I would accept above it. Alright. And going down to 8. So that was product rule. And here comes quotient rule. So quotient rule, this is always a lot of fun. Let's start by doing the derivative of the top. So that's just -3 times 2x plus 1 minus, now I rewrite the top, 5 minus 3x, times the derivative of the denominator, which would be 2. And this is all over 2x plus 1 squared. So now the rest is algebra, which I'm sure you're relieved, but at the same time kind of curious, okay, how's this going to work? I'm going to distribute in this 2, but I'm also going to put in the negatives. So this would be 10, but minus 10. This would be minus 6x, which would become plus 6x. All over 2x plus 1 squared. And we're probably going to finish up here in the next 5 seconds. So I combine my 6x's, they cancel out. This is -13 over 2x plus 1 squared. There's your quotient rule. Okay, and last but not least, let's go to 9. So we're going to find an equation of a line that's tangent to f of x at 4, 1. So I'm going to rewrite this in a more friendly form. So if I don't want to do quotient rule, I don't really have to do it. This would be to the -2/3. Okay, so now I'm in an area now where I don't have to do quotient rule. I can just go ahead and do chain rule. So if I'm going to do my derivative, f prime of x, this would be -2/3 times 1 minus a half x minus 5/3 times the derivative of the interior, which is -1/2. So let's go ahead and simplify this. These 2's are going to cancel out. It's going to be a positive 1/3. And I'm going to have 1 minus, sorry about the mark there, half x. This will be to the -5/3. There's your derivative. That's probably the easiest way to do that. So, check. Now let's find the slope. Well, we want to know the slope when x is 4. So I'm going to go ahead and put 4 in here. So I'm going to have 4 prime, f of 4 prime of 4. And this will be 1/3 times 1 minus a half times 4, and this is the -5/3. So, let's go ahead and do a little bit of this. Half of 4 is 2. 1 minus 2 is -1. You're going to do the cube root of -1, which is -1, and then -1 to the 5th is going to be -1. It goes on bottom. So technically, if you wanted to write this out, this would be 1/3 times 1 over -1. We all know what that is. That's going to be a -1/3 for our slope. So slope is -1/3. So check. Got the slope. Let's find the y-intercept. Okay, we know we're going through 4, 1. So 1 equals -1/3. 4 times that plus b. So this is 1 equals -4/3. We're going to add that 4/3 over. Okay, and that will be, sorry about the buzzer, that will be a positive 7/3 for b. So, intercept has been found. All we have to do is write our equation, which will be -1/3 of x plus 7/3. And there's your tangent line. Alright. Okay, now as you can see in 10 here, I don't have enough time on this video, so if you want to see number 10, check out the next video. See you guys soon. Ciao.